is a free format. But you have to include your cover page, include your marking rubrics.
Sir, I have a question. It's not really regarding this topic. Can I, sir?
Yes. Who's that?
It's your.
Okay.
Uh-huh.
Yes. Go on.
Okay. Because I joined this AI deep learning workshop last week, right?
Ah.
I have this one question. I realized that usually how we train our AI model is by it's by giving them a whole data set of maybe like
Sure.
Consists of like maybe 10,000 pictures.
Examples, correct.
10,000 pictures, and then throw in there, and then tell them that these pictures are for this picture is showing a certain thing, like for example, maybe a human face, or maybe an object like that, and then we just give that like that, and then we use some technique to like maybe image processing a technique like that, then to then train the model. So but then I'm curious if there's any like any other like method for training, for example, or for example, let's say in a picture, right? For us as a human, it's very easy for us to distinguish like, oh, this thing here is for example, this thing here is a ball, and then this thing here is a person kicking the ball, and this thing another here is suddenly there's a photo boom of a dog coming out like that. Then, for example, if let's say we were to present this picture, to a kid, and then let's say the kid doesn't know anything at all about what is a ball, what is a human, or what is a dog like that, the way how we don't I mean the way how we let them learn, right? It's not like we go give them 10,000 pictures of this like similar pictures for them to learn about it, right? What we can I think like for us, we more efficient if we go there, give them one picture, and then tell them, oh, this shape, right, is a human, this shape is a ball, this shape is a dog, like that. Look, so I was wondering if like there's any like this kind of like technique of training in AI also, because so far yeah, I mean like what I've seen like, it's just basically giving data set, let them figure out what is the similarities, and then if not mistaken, I read one article before that the training mode, these people use like really a lot of like pictures or data sets for to and then put into this kind of this training model to detect a goat lah. And then somehow when they test the model again, right, somehow a picture of there's a one picture with nothing inside except like a except the grass field only behind, but then that one is still detected as a goat, like that. Because apparently the AI learned that any picture with a goat inside is actually have the grass behind. So yeah, I was curious, like, I mean, like, it's like I give you this data, you figure out yourself. This data inside, I give you this picture. The inside has a goal lah for each picture. So you try to figure out how to like analyze this picture like that. That is what I seen lah. So I'm really curious if there's any other technique like to like maybe give like an initial knowledge about what to be expected, or like what to look for picture like that.
Okay, Christopher, you have a long comment. But it's good. I pick up a few things there. Some of the things you actually talk about will be not everything. Some parts of it will become clearer as you go along in the next few lectures and next few weeks, because we are also touching on artificial neural networks. We're also touching a little bit on the deep learning, right, and other methods.
Okay.
But go back to one of the things I pick up from your message so far, your comment. Basically, you're saying that I think basically you're saying that why do we need so many examples to show to the AI system? Right, 10,000. I think 10,000 is not a lot. I've heard of stories that this lady they spent 1 year and a few million USD to actually hire a team of people to call what we call annotate each picture, which is back to your point. This picture actually, if I annotate correctly, I employ a whole team of people to say that I give you a picture. What should the system tell me of this picture? This picture shows a picture of just a grass, and that's it. This picture shows the picture of a grass and a goat. This is part of what we call scene analysis. It's a very tricky, very tough problem to solve. So back to your comment. I think one of the things I picked up was that you said that why do you need to show this machine the 1 million pictures? Why you say look at the human child? We don't need such pictures to learn. Right? That's what you said, right? I think
kinda more,
but you look at it, for humans, like now you're looking at things. Your brain is processing information. For example, I'm looking at the that way's picture, and so I think because you see his face from different angles all the time. So in terms of a picture, is one picture, but in terms of looking at a human face or whatever, you're actually real time, isn't it? So and imagine if you're sampling at 1 picture per second. If you look at his face for 1 minute, you already have 60 pictures,
True.
And then the next thing also, I think so far, before 2009, before the what do you call it, the one on the game Go, the one that won the competition, AI was struggling because of the deep learning and because of the few steps, which is more processing power and more powerful algorithms. That's why it was successful. Before that, they're struggling. Why? What we call the extract features. So from I think your earlier point, I think your classmate Brenda is looking at this. We're trying to estimate what is the potential yield for your oil palm fruits, and this has actually big commercial value for people like Genting plantations. I want to look at the fruit, and I want to say that based on this fruit, I expect to have 10 liters of oil. But based on this color, I will make 5 liters of oil. So we are trying to do that. But in the case of Brenda, she's not looking at what you're doing, which is show the machine images. We are trying to extract just the color, a value. The color is red, right? This is 200 in terms of intensity for red. The other one is actually another value, which is 50. Maybe it's a darker one. So using that feature. So before the 2009 or 2007, before those days, we're looking at this method. Actually, even worse. We have to extract the features. So in case of humans, I think we'll look at this later on in the next few lectures. Okay. So for human face, if you're not showing the human face itself, you extract features. What's the distance between your 2 eyes? What's the color of your eye? What's the color of your hair? What's the color of your face? Our value. Even worse, accuracy is lower. So back to this, if you cannot afford to have more samples, you suffer in terms of the accuracy. So this is actually the more the merrier. The more examples you have, the system will be more accurate. But it suffers from the other part, which is it takes a lot of computing power. I think those of you are working on this in your FIP, please be warned. You need lots of computing power. Even though if you were to download the other people's trained system. But again, I can also challenge you. If you use other people's trained system, what they train on. Which is back to Christopher, your earlier comment. I can only show you pictures of dogs or cats. Tomorrow, if I give you another picture of an elephant, your system will struggle.
True. I understand.
So, but what's the good news? It's still in progress. Work is still in progress in improving the system. So we're not there yet. Sorry.
Yeah,
but it's much better now.
I'm just because I'm just
Christopher, before I hang on, before the next thing,
okay.
Before you guys get excited, with all these things, you look at the market itself. Look at the newspaper. What do they say? AI is the savior. right?
True.
We're not there yet. Only specific cases. We should see later on in the next few lectures. Yes, your question?
Because for me, I understand that the needs of big volume of data lah, because
Yes.
that one cannot run away
Run
from
away.
it already. Yes. But what I'm curious is because if we just like if our training method is just based on a big set of data, right, a big set of pictures, like it might be it doesn't guarantee that the AI will learn it properly. It might learn the wrong thing. Example, like I said just now, the article that I read, they train with really a large number of data just to find a goat in a picture, and then somehow what the AI learn, right, is actually the goat
relationship
means the grass field behind instead of the goat itself.
Yes.
So I'm curious, like if there's any a technique for us to, at least before we give them the data set, right, we also teach them to maybe tell them like what to look at. Basically, like instead of like relying on them learning themselves based on those data set, they also know like what to learn and like what to expect, kind of like that. For example, like maybe it's in like a human talking in terms of human, maybe like in a picture we circle where is the ball, where is the dog, like that in a picture to a kid, and telling them, okay, this is the dog, this is the dog, this is the human, like that. So I'm curious if there is a technique for that. I see a comment here.
I think I saw some comment from your classmate. I think Wong.
Supervision deep learning. Oh, okay.
Supervised. But again, there's the other approach, which is supervised. The danger is, I think if the unsupervised, I'm hoping the system will pick up things I don't know. You see, based on our just now earlier example about this oil palm fruit, the yield estimation. As a human, I think, as an expert, I think it's based on color. But if I were to throw the picture of the oil palm fruits to the system, maybe it pick up certain things that I do not know. So those are what you call features. Right. So based on what you're saying is that the system doesn't realize that in a picture, green doesn't mean there's a goat. Right. So this is example of what you call overtraining. So there's also, now question is, how do you ensure that the system learn enough? Right. So so there's also another area of research. So they say that you should not try to overtrain the system too much. You keep showing it. Okay, there's also the other part. Maybe in this case, your system, your data set contains too many pictures of green, empty fields. There's also this part. If you have more data of one type versus the other types, the system will actually ignore the smaller parts already, right? And again, based on the earlier comment, there's also another field of research going on, which is if I need 1,000 is not considered very large. 1,000 to me is larger because for us to actually collect data, imagine for our classmate actually doing some work on this oil palm to actually look at color. So we need lots of pictures of oil palm, and then of course we need to measure based on this color, what's the actual oil yield, the yield of the oil. So we need to do actual work, right? We need to take the picture, and then from there, not the picture, we also take pictures from different angles, right? And then also need to then extract the oil. That takes a lot of effort. So even if I were to collect 1,000 images or 1,000 fruits, a long time, expensive, painful. So what can we do? What we can do is that something called data augmentation.
What
the augmentation? So we actually artificially create more images. Cheating.
Oh, okay, I understand.
So for example, I have one image, actual image, and then I rotate it a bit. Let's consider a new image. I rotate again, another image. I flip it around, another image. So that's how from one image I can create another 3 or 4 more. So from 100, I can create 500, 600 quickly. Because generating data itself is expensive in that sense. A lot of effort, right? And then if you're working with the industry, you ask them for 1,000 for free. They say don't kacau me, right? So you know, it's not easy to beg for to beg for such data. So this is one of the things you will face when you do a industry project.
Okay.
So back to your question, I think what I can say is that the system itself, I mean, to me, I look at history of man. I mean, man as in woman included. We can never arrive at a perfect answer, full stop.
Okay.
If you have that perfect solution, as I jokingly said in class before, I'm not sure this class or other classes, the manufacturer won't like it. You know, what else do I do? Because look, I think I gave an example before. I think in my other classes, you look at one example, which is your blender, fruit juicer blender, right? First version developed by Panasonic. First of all, it's new. Instead of using your hand to cut your vegetables or your apples into small pieces, this blender will do it for you quickly. Then people found out, hey, I can do an improved version. Then before you know it, our Malaysian company, Panasonic, Alba, and a few more, say I can do that. Nothing much, but I can put in a motor, put in a cutting knife. I can do it. I can sell cheaper than you. So now what did they do? They actually come up with a slow juicer. So you see, every time technology moves, someone will try to improve it. That's what they call human innovation. And all up to you guys now in the near future, when you guys will produce new answers to the current problem that we face. There's a high level explaining where technology is and also some of the issues you raised. And of course, there's a lot of work being done. That's why we have this research. That's why we have universities. That's why we have research projects to improve it. And I think many of you are doing that in your FIP. Otherwise, your lecturer cannot publish or you cannot publish. What is new in your project? You have to answer that part. So back to you. If you are doing something on your FIP along the line, you say, okay, I will do something to improve it. But then again, I think I think our classmate mentioned, there's also what supervised deep learning and what else? The image augmentation and things like that. One thing that's frightening to me is what? The internet is frightening. Your idea, maybe someone think of it before, especially from China. You have a few million scientists, good scientists, smart scientists working on the same problem. They also have the pressure to improve the solution. And they have resources which you don't have. And you guys are looking at projects which you fork up on your own pocket. They have the government sponsor them, and they have also a lot of industry sponsoring them. And they have many, you look at the papers, how many of them are Chinese?
True, yeah.
Whole army, before you come up with the answer, someone somewhere in China will think of the same answer. Right? So that is the pressure of working quickly. And all this on the good side is that as a society, as a human race, we will keep improving. Otherwise, things cannot be stagnant. This is more on philosophy already. Things that, as a human race, we will keep improving. But on the other hand, we also things like contributing towards global warming, for example, right? Things like that. So you're right. It's good for you to think of such things, right? And some of these things can also be part of your, if you want to later on, maybe go into deeper. But you find that if you go deeper and deeper, you find that there are more things you don't know.
True.
So good. Keep it up. Anyone else? Any comments to add?
Not really, Lester.
There's one question here. What's the thought on deepfake? One interesting one. Because I think there's some work being done. I think where they see this, and because why? Because who is it? I think let me check who is it. Su Wen, Tang Su Wen actually is looking at the next part of Christopher's question. So the question, the comment is, as the technology improve, in the case of Christopher, the deep learning will actually come up with able to create realistic, say, images, right? On the other hand, because of that ability to create very realistic images due to technology, someone being cheeky come up with a funny version of that. It's a fake of that picture. So of course, I think it's always to me again a philosophy. It's always a bit of a conflict between the good and the bad, evil and good. If you look at religion, devil and the God, same thing. So the deep fake will be the, I would say, evil side. So, but then there's still work. So I cannot use deep learning to actually detect the defect. There's some work being done there, a lot of work being done there. Because I know it's so easy now with all the tools available to create very realistic pictures. And this can actually damage society. Right? So to me, it's if you ask my thoughts, I think I look at it as neutral. I mean, I don't like it or whatever. I don't like it or I don't hate it, but just that, of course, look at humans. There's always the good and the bad. The good ones will not do that. The bad ones will do that, for either for money or for other things. So it's then again back to technology. The good guys to actually come up with technology to able to detect the deepfake accurately. Actually, what I now said is that we can have this conversation face to face. Especially with COVID-19, I'm always staring at my screen. Okay, good questions. Anything else? Actually, I enjoy this because at least I know some of you are thinking and then interested in the technology. Anything else? I can help you. Comments, welcome. At least a bit of chit chat. Otherwise, I'm always staring at the screen, working, and then go back and sleep, and then the next day repeat the same cycle until this thing ends.
For me, that's all. Thank you, sir.
Okay, good. Welcome.
Okay.
Have a nice weekend, you guys.
See you, sir. Bye bye.
All right.